I'm Zeming from China. Today I will give a report from following four aspects. As is well known, after a long time execution in Android system, applications may become no response or stop running due to performance degradation, system crashes, or program cumulative failures. These phenomena have been validated to become common in mobile systems, which is caused by software aging. To handle the software aging, software rejuvenation is an efficient way. In order to make rejuvenation more efficient, identifying the aging state of Android system operations is the key point. Currently, there is much problem about software aging research. Firstly, we found that in the Android running environment with complex mobile application combinations, the definition of system state boundary by artificial is not universal. Secondly, the accurate and comprehensive Android system running data are difficult to obtain in time, and such insufficient dataset often make traditional machine learning and shallow neural network hard to perform satisfactory system state partition. In this paper, we proposed an Android system aging state detection method based on the boundary equilibrium generative adversarial network and k-means, which is named as GAN-ASD. GAN-ASD has two major contributions. Firstly, based on the sample dataset of low quality, we could use the GAN to produce improved datasets to better reveal and represent the system running status, which provides guarantee for system aging state detection. Secondly, based on GAN-ASD, Android system aging state could be determined in real time, which is used as the befitting indicator to perform precisely rejuvenation operations to ensure the reliable running for Android system. The architecture of GAN-ASD as follows. Firstly, interpolation clipping process is used to process the time series dataset, which is constituted by the sample of Android aging indicators. Secondly, according to the time series dataset, GAN will generate the dataset which has software aging characteristics. At last, we use the generative dataset to train a k-means clustering model. With the trained model, we can precisely determine whether the current Android system enters into the aging state or remains in the normal state. As for Android aging indicator, we choose CPU using rate, memory using rate, and frame skip rate. We consider this function can suggest the performance of Android device and the experience of users. During Android system running, certain apps may crash, response to timeout, and so on. It is difficult for the system monitor to obtain the current system running data sample, especially when the system enters the aging state. This phenomenon seriously affects the occurrence of the subsequent accurate rejuvenation. So, three interpolation methods could be used, that is, maximum interpolation, average interpolation, and forward interpolation. As for clipping processing, because of the length of the obtained time series is difficult, but the input to generative adversarial network is fixed. According to practical experience, we cut the dataset length to 512. There are two cutting methods, that is, random clipping and forward clipping. After processing the system running datasets, we put them to GAN as input datasets. When generative adversarial network achieve Nash equilibrium, we can get the generative running dataset from generator, which will learn the characteristics of system running datasets. Then we train the k-means model with the generative running datasets. So as to obtain a software agent detector, we divide Android operating system state into 3 states. That is, healthy state, sub-healthy state, and aging state. The clustering algorithm divides the generative dataset into 3 corresponding clusters. After training, we put the real-time AI samples to the K-means model. If the sample is just to the aging cluster, we determine that the system enters aging state and performs suitable rejuvenation operation. We restart Android device as a simple rejuvenation operation. In order to validate the effectiveness of the GAN-ASD, we use 2 evaluation criteria in our comparison experiment. One is rejuvenation coefficient, which elevates the user experience, and the other one is rejuvenation frequency, which elevates the rejuvenation cost. Next, let me introduce the experiment. The first experiment is restart aging experiment and the interpolation clipping process. We write testing tools in PC segment based on Python include Android load generator tool and Android performance monitor tool. We use the Android debug bridge to connect the phone to computer, and the PC client runs the load generator and the performance monitor to get the Android runtime system-related parameters. Before each restart aging experiment, we restart the phone to make Android operating system healthy. System monitoring program records CPU using rate, memory using rate, and frame escape rate. We will stop the experiment when we can't get any response to system, except for the restart operation. We conducted 7 experiments to get system running datasets. Then we will use system running datasets to perform 6 combinations of SAP to obtain 14 pieces of tensor size of 512 multiplied 3. Then we take the generative running data comparison experiment. This experiment is to get a more suitable combination of interpolation, clipping process, and GANs. From table, we can see that generative running data sets processed by maximum interpolation method access 0 to 1. It is obviously not in accordance with law. The loss function of generator in original GAN accesses 1 to prove that the network doesn't converge. Although the loss of WGAN and WGAN-GP is less than 0.01. Compared with the maximum and minimum of original data, we found out that their divergence is too large since relatively simple generator decrease meters. Network structure doesn't adequately learn characteristics of system running data sets. Thus, the maximum interpolation method together with GAN, WGAN, and WGAN-GP are not chosen by our studies. The picture shows the results of generative running data sets with forward interpolation, forward clipping, and begin. Then we take the cluster algorithm comparison experiment. In this experiment, we have to select the most appropriate combination of interpolation clipping process and the clustering algorithm. The clustering numbers are all set to 3 by adjusting the parameters in each algorithm, and the clustering evaluation index is a Sahara index. It is obvious that K-means algorithm with forward interpolation, forward clipping processing has the highest profile coefficient and the best clustering effect. The clustering effects using combined forward interpolation, forward clipping, The GAN and K-means algorithm is shown in figure from the aspects of time series and Android aging indicator space. States with number 1 represent healthy state cluster. States with number 2 represent sub-healthy state cluster, and states with number 3 represent aging state cluster. While in the later figure, the green states represents healthy state cluster, the orange states represents sub-healthy state cluster, and the blue states represents aging state cluster. Finally, we can verify whether K-means model based on forward interpolation, forward clipping, and BGAN can accurately detect system states in real Android running environments and accurately perform the rejuvenation operation in aging state. Compared with the fixed interval rejuvenation and random rejuvenation, accurate rejuvenation based on GAN-ASD can effectively reduce the cost of rejuvenation. When the sample is just to be aging, we execute the rejuvenation stage to restart the phone and repeat the above process after restarting. We calculate the rejuvenation coefficients and the rejuvenation frequency. The results are shown in table. It is worth noting that our rejuvenation experiments have been carried out several times, and the rejuvenation cycle is optimized as much as possible so that the rejuvenation coefficient is minimized. Using GAN-ASD, precious rejuvenation achieves smaller rejuvenation cost and rejuvenation frequency, which means less rejuvenation operations and lower application launch time. It demonstrates that GAN-ASD could get lower rejuvenation costs and better user experience. So, according to these experiments, we can conclude that first, the time series generated by the GAN is the best than other GANs. Second, it is the best of clustering effect of forward interpolation, forward clipping data processing method combined with K-means. Thirdly, the precious rejuvenation method based on the GAN-ASD can balance the cost and the effectiveness of rejuvenation, which proves the effectiveness of the GAN-ASD method. This is my report. Thanks.